Alright, for number 4, we're looking for the x and y intercepts of this line. 3x minus 6y equals negative 12. Remember that there are 2 ways to do this. One, you can solve for y, graph it, see where those intercepts are. Or you could cover up one term, solve the other. So what would y be? Negative 6y equals negative 12. If you solve for it, what would y be?
2.
Positive 2. I covered up this middle term and set 3x equal to negative 12. What would x be? Negative 4. Guys! Yes.
What did you say?
Wouldn't y be negative?
No, because these are both negatives and the negatives cancel.
Exactly.
Right, so make sure you have that one written down. And pass up your answer sheets.
No, it was
Just to refresh your memory, we are going to take this quarter test. It's going to be on the objectives. All of Unit 3, so that was finding slope, graphing lines, finding the transformations. Your line of best fit test. And then all of Unit 4, so that was what we took right before break. If you have not taken Unit 4 or the line of best fit, you need to do that today or tomorrow morning.
What's Unit 4?
Unit 4 was writing equations of lines and writing equations of parallel and perpendicular lines. Alright, so we can do each of these and then we'll do one of these next pieces. So we need to find the slope of these graphs. If there are not points on the graph already, you will need to find 2 points that cross lines perfectly. Bless you. What would the slope of this be? Negative 2 over, what was the second number? 7. Good job. So remember that you could start at either point and go down and right, or you could start at this point and go up and left. Now, for 2 and 3, we need to remember Koivuk's.
I don't think you do the other way.
What is the other way?
Like I went up 2
and left 7?
Yeah.
That's fine. It does not matter because you should get the same thing either way. The only way you wouldn't is if you didn't count the spaces correctly. Okay. For number 2, is this a horizontal or vertical line? Horizontal. So that means it will have what type of slope? 0. This is not asking you to find the equation. It's not asking you to graph it. It's just asking for what is the slope of a horizontal line, or what is the slope of a y equals. So if you put 3, that would be wrong. Right? For this one, is this a horizontal or vertical line?
Vertical.
Vertical. So that means it has what type of slope? Undefined. Right? So for your slope, remember that it's rise over run, or your y's over your x's. I'm just going to put that down as a side note. Always, don't switch those. But if you have sets of points, then you're doing the y2 minus y1 over x2 minus x1. Remember that you can change the order. You could put y1 first and then y2 as long as you put x1 first as well. If you only switch one, you're going to get a negative or a positive when you shouldn't have. So label it if that helps you. And then put that into that format. So -6 minus 2 over -1 minus -5. Remember that you're always subtracting. So if you're subtracting and you have a negative, those come together to make a plus. -6 minus 2, -8. And then -1 minus -5 is +4. Can this be simplified?
Yes.
To what? -2. So if it can be simplified, simplify it. Okay. I'm not going to do 4 because I want you guys to do that, so you'll have time, hopefully, to do that later. Fifth period had like 10 minutes left, so it depends. We'll do one more base. For 6, what's our slope? -1/2. It's already in slope-intercept form. You don't have to do anything except know which one is the slope. For types of questions like 7, use Hoy-Bucks. It's asking for the slope, so you shouldn't put 4 in here. Your answer for those type of questions should be 0 or undefined. We'll start this one and then we'll see how much time we have. Let's do 9. So for this one, could we say what the slope is without doing anything? No, so I shouldn't see you do that either. We need to solve this first. How would we solve this to put in slope-intercept form? Subtract x from both sides. So -3y equals -x plus 3. Remember, I'm switching this so that it's in slope-intercept form. And then what? Divide each piece by -3. What would this become? 1/3x. This part isn't really necessary. What's our slope? 1/3. Right? We will continue when we get back from lunch, so you can go grab your phones. Slope part of this. I'll see when we go to work. Alright, on the next page. We're going to do one of each type of problem. So for anything that says x-intercept, y-intercept, or if it gives you 2 points, I don't expect you to do anything else except plot those 2 points and wrap the line. So for 11, your x-intercept is going to be on your x-axis, where x is 4 and y is -1. And then you're going to make a line through those 2 points. You're not using slope here. You're just making a line through those 2 points. For the next two, graph the points, connect them. And remember how to graph our order pairs. So for 3, -1, I'm going to go to the right 3 and down 1. And then I'm going to go -2, so left 2 and down 3. And then make a line through those 2 points.
Wait, so is it X1 and X2?
X1, Y1, X2, Y2.
Yeah.
That was a little perfect. So for those, plot the points, make a line through it. Also, make sure these have arrows because they're lines that keep going on forever and ever. For one like 15, it tells you what your slope and tells you what your y-intercept is. So how would we start graphing this? How would we start this? Put the y-intercept there, so at -4 on your y-axis. And then to get a slope of -2/3, what directions could I go to get a negative slope? I was going to say my left and your left are two opposites right now. Just say it. Left. If I went left, which way did I go vertically? Up. So remember, you're always going vertically first. What? Not on this, but what other way could we have gone? Down and right. Right? So up 2, left 3. Can we go up 2 and left 3 again?
No.
No, we ran out of space. So just those 2 points. But if you could keep going, do as many points as possible. For 17, where would we start? The y-intercept, which is -1. And then we have, again, a negative slope, so up and left or down and right. Remember, we can't go left and then up or down. We can't go right and then down. We have to go vertically first. Remember that anytime you have a whole number, it's really over 1. So we can go up 3 and left 1, or we can go down 3 and right 1. So do that as many times as you can. And you should be able to get 4 total points. Yes. First, because of your slope. Your slope is always your y's over your x's, so you have to do something vertical first. On the next page, we're going to do one of these and one of these. Which 2 do we want to do? 18. And so one of these and one of these. 19. So when this is in standard form, you can do this one of 2 ways. Remember, one of these ways doesn't always work, but I'm still going to give you the option. You can solve this so that it's in slope-intercept form. How would we get this in slope-intercept form? Subtract 4x from both sides. And then divide each piece by 5. So y equals -4/5 x plus 4 you could graph your y-intercept, then graph your slope, or use your slope to graph another point. So here we would go down 4, 1, 2, 3, 4, and right 5. That was really perfect. The other way we could do this is by finding our x and y intercepts. So remember what we did in our shark bite. It'll be the same thing. Cover up one of your terms, solve for x or solve for y. What would x equal if we covered up the y term? 5. And then what would y equal if we covered up the x term?
4.
4. Now in this case, these happen to be the same points. That doesn't always happen. This method does not always work because these numbers have to be divisible. If they're not, it won't work. But that is an option. For 19, how are we going to graph this? Or what do we need to use to graph this? What about us? So somewhere on this test, you should have written this at least once. Right? So this is an x equals. What type of slope will this have? Undefined. And what type of line will this be? Vertical. So wherever x equals -3 on your x-axis, make a vertical line. Mine is kind of crooked, but that's okay. Do we have any questions on the graphing section? So the next section was your transformations. We're going to do all of the transformation ones because that was the most missed section on that test. So we need to recall a couple of things. Anytime it's talking about the word shifted up and shifted down, it's talking about either your slope or your y-intercept. Does anyone remember which one it was? The y-intercept. So this is talking about the y-intercept. The shifted up or shifted down is always your y-intercept. Which means if it's talking about steeper or less steep, it's talking about slope. Right? So 1 and 2 are asking for two things. To describe what happened when the transformation was applied, but also to graph that transformation. So here, if I subtracted 3 from the function, what happened?
It went down.
It went down 3. It was shifted down 3. The 3 part isn't necessary, but it was shifted down. So that means I'm going to take my entire function and move it down 3 points. I cannot see some of these points. And my eyes are watering because I'm so close. Okay. Did our slope change? No. Did our y-intercept change?
Yes.
Yes, so it was shifted down. Our y-intercept was shifted down 3, and that's the only thing that changed. So this is another side note just to know. Another good side of this. So the y-intercept change, not the slope. For this one, if I am multiplying 1/2 to the entire function, what happened? So it didn't shift, but it didn't get steeper, but less steep. Because if the number is less than 1, it got less steep. If the number was like 5, it would be steeper. So this one got less steep. Now in this case, if we're multiplying the entire function by 1/2, and our slope was what for this original? 1. So if our slope was 1, if we multiply it by 1/2, our new slope is now 1/2. So start at 0, 0, and go up 1 over 2, up 1 over 2, or down 1, left 2. Once you have that graph, you should be able to look at both of these and pretend you were sledding or skiing or whatever you do down hills. Which one would you get down faster? The original, which means it's less steep. Right? So in this one, did our y-intercept change? No. What did change? The slope. So when it's steeper or less steep, your slope changes, but not your y-intercept. I'm going to put that off to the side. So the slope changed, not the y-intercept. Right? If we're looking at number 3 and we are comparing these two functions, f of x equals x and g of x equals this new function, anytime it says f of x equals x, that's your original. Was our new function shifted up or shifted down from the original?
Shifted down.
It's shifted up. How do we know it's shifted up? Because of that positive 3. Remember, anytime it says shifted up, that's your y-intercept. You're looking at what changed. Now, is this steeper or less steep?
Steeper.
It's steeper. So even though it has that negative, and I said it's less than 1, really we disregard that. You could also graph these. So I think I have my graph. So I'm going to graph these really fast so you see what they look like. Okay, so the blue is your original, the red is your negative 5x plus 3. Which one would you get down faster? The red. So it's definitely steeper. So if you're not sure, graph it. Right? Questions on these? Yeah. If the y-intercept is negative, it's been shifted down. Alright. For number 4. Let's focus. For number 4, it's comparing our original to this function. So I'm going to outline this in red just so we see it a little better. If it's comparing to the original, well, the original's not drawn. You don't have to draw it in, but just so you see it, I'm going to. So it's going to start at 0, 0, and go up 1, over 1 to the right, and then down 1, left 1. Right, so we are comparing these two lines. This first question is asking about the slope. What is the slope of this red line? The one that was already drawn in.
1/5. No, not 1/5. What am I saying?
It should be 4 over 1.
1, yeah. I know.
So this slope was 4. What is the slope of the original? 1. So we are comparing the slopes. What did we do to 1 to get 4? Did we add 4 to 1 to get 4? Did we subtract 4 from 1? We multiplied it. 1 times 4 is 4. Anytime it's talking about slope, you are multiplying or dividing. Yes.
Wait, so you bring the original one back to compare it?
So the blue you did not need to draw in,
Oh,
but it's
okay.
comparing it to that.
Okay.
Right? For B, it's comparing the y-intercepts. What is the y-intercept of the red? -2. What's your y-intercept of the original? 0. So it's subtracted 2. Anytime it's dealing with y-intercepts, that's adding or subtracting. For number 5, it's asking you to determine what this new graph would be if it was shifted down 2 units and it was 3 times as steep. What do those two sentences tell us?
It's shifted down, so not like -2.
The y-intercept is -2, and Kylie, what were you saying? The slope is going to change how? It's going to get steeper,
So 3.
so the slope is now 3. Okay, so those two sentences help us figure that part out. But it's really wanting us to plot 2 points that go with those two sentences. What would 1 point be as an order pair?
1 over. What is it over there? 1 over 1?
1,
1, yeah.
that would be 1.
Because it's 3 over 1, correct? Because it's going up to that. So yeah.
0, -2. So if you started at 0, -2, and you use your slope, you could go in either direction. Up 3, right 1 to get to 1, 1. Or you could have went down 3 and left 1 to get to -1, -5. But you only needed 2 of those points. Jackson, put your phone on. Questions on that one? Okay. We are only going to do one of these line of best fit questions, but does anyone want an iPad to use? If you do, just raise your hand. I will bring it around to you. Otherwise, you're going to use your calculator.
Oh yeah.
What did you do?
Yes. That's what I was getting to it, but I
Yes,
accidentally
ma'am.
did.
When you get an iPad, go into test mode, Desmos.
At least turn. No. What's up, man?
Misfire.
Wait, you can do some calculator, right? How? No. This is
What is not screwed?
Pig. Alright, do we want to do example 1 or example 2 together? Example 2, okay. Alright, so I'm going to do this simultaneously in Desmos and in your calculator. So those of you on your iPad, you would go into Desmos. You would go into your plus, add a table, and put those values in. Those of you using your calculator, you may need to clear out your graph. So reset your calculator really fast. Second plus 712. Switch those. Right, and then go into stat, edit. Put your grams of fat in L1 and the calories in L2.
What did you press? I'm sorry.
Stat, edit.
I don't remember how to do it.
Why do you?
I don't know. I just remember how to do it. You said it. I heard that. I'm literally right there. Right, and there. Oh, okay. Yes.
Oh, I missed mine.
I still need to make this.
So we had to change it over, or we're gonna just update it as it is.
Put it in as it is.
Dang, I'm trying to learn.
Chris.
Alright, once you have your tables, whether that's in Desmos or your calculator, so I'm going to start off with your calculator first. Go into stat, then scroll over to calculate. And then do number 4, linear regression number 4. Then in your calculator, you're going to store it. So once you get down to store, hit alpha trace. choose one of these, it doesn't matter which one. And then hit enter. And you should get these two numbers. On Desmos, you need to type in Y1. You need to find your tilde that's in your keyboard. Click on ABC. It's right here. MX1 plus B. And you should get those same numbers, except minus off. I don't know what it is. Oh, because I put 650 in There we go. Now they match. Why are we out of our seats? Have a seat. All right. Now, yes, Ivan. Yes.
So you use
What?
A sticker?
When
did you see that? I was like, what?
Alright, remember that when it's asking for linear regression equation, that's the same thing as line of best fit. So we're gonna shorten it a little bit. If it doesn't say to round, you can either use all of the decimals, you can use up to 1 decimal. I would use at least 1 decimal. So y equals 14 point, I don't remember, 4
So how do you know when to round
x. If it says to, then yes. If not, use at least 1. Plus 133.9. Is that right? Okay. To do the next two pieces. In your calculator, you'll need to change this equation. So go into y equals. It has all of the decimals listed there. So if you clear it and rewrite what we just wrote, 14.4x plus 133.9. Retype that in y equals. For everyone using Desmos, you have to add a new line. Type that equation in. But once you type that in, you have to go into your settings wheel and click your table. Okay. So on your calculator, go into your table, and we're looking for the total calories for a sandwich with 35 grams. You can either scroll all the way down to 35, or if you hit second window, you can go exactly to 35. And you should get 637.9. On Desmos, you would just put that into your table. So if I put in 35, those numbers are different. I don't know why.
Wait, what did you put?
Oh, I put 34, not 35. Okay. 637.9. Should be your answer for that one.
I have a question.
Yes.
When you went to the table, right? What button did you press to go find like the number?
Second window. And then you have to go back to your table. when you do these problems, you have to think about these realistically. Could the total number of calories be a decimal? Yes, they could. Now, in this case, none of these calories have decimals, but that's okay. Your answer can be a decimal. What's your question? I don't know where you are in the process. Change it to 35. Then go back to your table.
Okay, you go first. We'll take it all.
Language.
Oh, sorry.
Like watch.
So for the answer, if it says to round, you have to round. If it doesn't say round, yeah, if it doesn't say round, don't round. Unless it's realistic. Look, people, animals, things you can't have decimals of. Okay. This last part, you can do one of two ways. Do it algebraically or do it in your calculator, except you can't do this part on Desmos. So now we're looking for the total grams instead of the total calories. So we are now looking for X, not Y. So you could set this up as 1,000 equals the equation you have, 14.4x plus 133, wow, 0.9. And you could solve for x from here. In your calculator, you see how these numbers keep going up? Remember, y is your number of calories. So if I keep scrolling down until y gets over 1,000, I get 61. So you should get the same thing either way. It is 61. But I'm going to solve this just so you have it. Someone do this for me. 1,000 minus 133.9.
Did you say 10?
It's 866.1. 66.1. Divide that by 14.4. 16.14. Rounded. So in this case, when you solve for x, you get 60.14. Now, if you round it down like we normally do, if we put in 60, we wouldn't get 1,000. We need to get over 1,000. So we have to round this up to 61. So yes, the answer is still 61. So you will have the option to do the line of best fit with Desmos. It will be the last section of the test, so you would have to come or ask me for that once you get there. You'll also get a tip sheet, the Desmos tip sheet, calculator tip sheet. Unless you already have it, then you could use the one you have. What's the answer for that? 61. It doesn't look like a 6, but it is.
I didn't do the top.
Yes. No, because we don't have much time. I can say that it will be on your tip sheet. Yes.
We have a tip sheet. Awesome.
Sure. Alright, on the next page, we are writing equations in slope-intercept form? So now that we are actually writing the equations, for if it's a slant, we need slope-intercept. If it's just a vertical or horizontal line, we need x equals y equals some number. That's it. So we'll do one of these and one of these. Which two do we want to do?
No, 1, 2, and 4.
2 and 4. Okay. So for 2, this is a slant. It's going to be y equals some slope plus or minus some b. What is our slope?
Negative 2 over 4.
Negative 2 over 4, which becomes negative 1/2. What is our y-intercept? Negative 3. So y equals negative 1/2 x minus 3 is your equation for number 2. Remember that we need our x's and we need our y's. If we don't have that, it's not a full equation. For 3, is this a horizontal or a vertical line?
3 or 4?
I'm sorry, for 4. For 4, it is a horizontal, yes. So, is this going to be a x equals or a y equals? Y equals. What number does y equal?
1.
Yes. Right. For this next section, we need to find our slope and we may need to find our y-intercept. So we can either do 2 of these and 1 of these, or 2 of these and 1 of these. We may have time to do 2 of both, but I'm sure. Shikai. 7. Wait, what?
9.
Okay, 9. Okay, 1 more. 8. Right? So we'll do those 3, and if we have time, we'll come back to them. Okay, so anytime it gives you a word like a vertical line through, or through this point with a slope of 0 or undefined, these two problems are very much the same. They're going to be solved very similarly using Hoy-Bucks. A vertical line is going to be x equals or y equals? X equals. What does x equal?
No.
Negative 2.
Oh, yeah,
Because you're given that point. 7 is going to be very much the same way. You have to remember what type of line will give you a slope of 0. Find which type of equation that would be, and then figure out which one it is. For 8, we're given 2 points. That means we need to find our slope, find our y-intercept. So let's find our slope first by using y2 minus y1 over x2 minus x1. So negative 1 minus 4 over 6 minus 1. What would our slope be? Not negative 3.
No, negative 5 over 5, so negative 1.
Negative 5 over 5, which is negative 1. Okay, so we have our slope. We need to find our y-intercept. You now have 2 points to choose from to help you do that. Which one do we want to use? Okay. You could use either, it doesn't matter. We're going to use this first one. So remember that this is x, this is y. We have m, we're looking for b. 4 equals, we're putting this in our slope-intercept form. -1. Just silence it. -1 times 1 plus b. -1 times 1 is -1. What would the value of b be? +5. But remember, that's not your final answer. Your final answer needs to be an equation. What would that equation look like?
Y equals -1 x plus 5.
So -x plus 5 or y equals -1x plus 5. Either one, doesn't matter. Right? Same thing for 9. We need to find our slope and our y-intercept, so we need to find our slope first. So 0 minus -2 over 4 minus -4. Yes. +1 over 4, because it's 2 over 8, yes. And then we can choose either point to find our b. I'm going to use this one because it has a 0 in it. So 0 equals 1/4 times 4 plus b. What's 1/4 times 4? 1. What is b? -1. So what is our equation?
Y equals 1/4 x plus 1. Oh no, sorry, -1.
-1. And we are in the last section. Writing equations of lines that are parallel and perpendicular. We can do one of these. We can do the first one. So we need to remember a couple things. What do we know about parallel lines? They're straight. They are straight.
They don't intersect.
They don't touch. What else?
They go the same direction.
Same slope.
The slope is the same. The y-intercepts are different. What do we know about perpendicular lines?
They can intersect.
They do intersect at a 90-degree angle. What else?
You don't have.
The y-intercepts don't matter. Negative reciprocal for the slope. Okay? So for these, you're just determining, are these parallel, perpendicular, or neither? For this one, you have to find your slope in order to determine that. So let's find the slope for both. So for AB, that's going to be 2 minus -4 over 18 minus -6. What would that be?
6 over 24.
6 over 24, which is 1 over 4. Okay. Now we have to do the same thing for CD. We need to find the slope of the other. So -4 minus 8 over 10 minus 7. Well, 10 minus 7 is 3. What's -4 minus 8? negative 12. Can this be simplified
Yes.
to what?
Negative 4 over 1 plus 4.
Negative 4 over 1 or negative 4. Are these parallel, perpendicular, or neither?
Perpendicular.
Perpendicular because they're negative reciprocals. One is the flip version of the other, and one is negative and one is positive. Remember that the symbol for perpendicular is the upside down T.
Wait, so will we have to do that?
What? The upside down T.
No, B.
B, right? The symbol.
Upside down.
It may show up, but you won't have to write it.
So we'll just have to find the answer.
Yeah.
No. Upside down T.
What'd you say?
Capital T.
Can you be quiet, please?
So if it's parallel, will it have the same?
The slopes will be identical. Remember, parallel is just two lines.
Well,
All right. For sake of time, we're going to do this one. We're going to do the hardest of these two. If we have time, we'll do the others, but I'm not sure we will. All right, so for these, you have to write a new equation that is parallel or perpendicular to whatever is already there. So for this one, I need to solve this equation before I do anything else. How would I do that? Subtract 3x to both sides. And then divide. Yes. Then divide each piece by negative 2. That is not the answer to your question. That just helps you find the next step. Alright, so we have a point xy. We need our slope to be parallel to this line. So what would our slope of our new equation that we're looking for be? 3 over 2. It would be the exact same. Because it's parallel. Right? So now that we have our slope and we have our point, we're going to find b by setting it up just like we were doing before. 4 equals 3 over 2 times negative 3 plus b. What is 3 over 2 times negative 3? 3 over 2 times negative 3. Negative 4.5 or negative 9/2 if you left it as a fraction. If we add 4.5 to both sides, what is b? 8.5. But remember, that's not your final answer. We need an equation. What is our equation?
Y equals 3 over 2x plus 8.5. No,
Y equals 3 over 2x plus 8.5. I circled the wrong one for this section. I should have circled that one. Alright, let's do this last one. Same thing, except now we are looking for a line that is perpendicular. So we need to solve this first by doing what? Adding x on both sides. And then dividing each piece by 3.
I have a really good question. Back to to that one on top right there. You know how you had like 4 equals negative 4.5 plus b?
Yes.
Wait, was it 4.5?
B
It was negative 4. So you got 8.5 when you
added.
to the 4, and then negative to the other side.
No, you just added it to one side.
Okay.
Alright, now our new equation needs to be perpendicular to this one. So what will our new slope be?
Negative 3 over 1.
Negative 3 over 1, or just negative 3. So now we're going to use this slope and this point to find b. So 2 equals negative 3 times negative 5 plus b. Positive 15.
It's negative.
What is b? Negative 13. So what is our equation? Negative 3x minus 13.
Wait, did you do negative 15?
No.
Either way. Oh.
Alright. So the rest of this needs to be completed by the time I see you next. Because your quarter test is next class.
Oh, why are you telling me this now?
Come gets.
Right? If you need help with any of this, if you need help with any Khan Academies or anything else, please come see me after school today. The Khan Academy that was due Friday, that is due this Friday. Listen, I'm gonna move to next week because we're not gonna have time to go over that. Leave your iPads on your desk. I'm gonna come around and collect them.